everyone. Today we talk about how we can use bond energy to calculate enthalpy change. First, let us remember energy profiles. If you look at an exothermic reaction, it's quite clear that the reactants are on a higher level than the product, and that the energy released arrow is going down, meaning that the energy is decreasing, because it is lost to the surrounding, making the reaction exothermic. In an endothermic reaction, though, energy of the reactants is lower than the product. This is why it takes in energy from the surrounding in order to reach the products and become products. Now let us consider the chemical reaction. What takes place? Yeah, I understand the reactants form the products, but how? In the beginning, you need to break the bonds in the reactants so that the atoms are free to make new bonds in the product. Now consider on the bond level. Breaking bonds will take an energy in order to break this attraction between the atoms. Therefore, we say it's endothermic. Oppositely, bond forming is exothermic, meaning it releases energy. If you look at this diagram, you will see that the reactants here are on a higher level than the product. And if you look at the energy absorbed to break the bonds, it is less than energy released when bonds are formed. So when you apply the equation, which is what we use to calculate the overall energy change, you see that energy taken in to break the bonds of the reactants minus energy released by forming the bonds in the product is delta H. Now consider this and apply it on the diagram. You'll see that the value is truly with the negative. If you calculate the bond breaking minus bond forming, it is with a negative value, and delta H becomes negative and the reaction is exothermic. Now let us see how we can do that from definition point of view. An endothermic reaction, we say that energy taken in to break the bonds in the reactant is higher than energy released when bonds are formed in the product. The difference in the value is very clear. Oppositely, in the exothermic reaction, energy taken in to break bonds in the reactants is less than energy released when bonds are formed in the product, making delta H value here with the negative value, and the reaction becoming exothermic. Looking at calculations, if I have a reaction of iodine with chlorine to give me iodochloride, you see that 1 mole of iodine bonds with 1 mole of chlorine to give me 2 moles of iodochloride. Now, the total value of energy required to break the bonds is bond 1 mole of I2 and 1 mole of Cl2, which is 151 plus 242, giving me a total value of 393. The amount of energy released when bonds are formed at the product is 2 moles of ICl, meaning 200 multiplied by 208, which is 416. The overall energy change, or the enthalpy change, is the energy of the bond breaking minus energy of the bond forming, making the value with negative 23. Now, as a conclusion, I know this is an exothermic reaction because the value is with a negative. And that's how we can use bond energies in our calculation. The sum of the energy of the bonds in the reactants minus the sum of the energy of the bonds in the product. And the overall value is the enthalpy change. Thank you guys and best of luck.